Hi, in this video, we are going to continue our discussion of parabola. In the previous class, we looked at the standard curve, the standard parabola, and some basic definitions. We saw that this was the standard equation of the parabola, and the graph of this parabola looks like this. This point is the focus. This is a random point on the parabola x comma y. This is the vertex, which is 0, 0. The directrix is here, which is x is equal to minus a. The axis of the parabola is y is equal to 0, or basically the x-axis. And the tangent at the vertex is the y-axis, which is x is equal to 0. So the latest rectum here is the line here perpendicular to the axis passing through the focus, and the length of the latest rectum comes out to be 4a. So this was the standard equation of a parabola. However, we have different forms of the curve. Sometimes you might have a situation where you have an equation like this, minus 4ax. So in this case, it is just a reflection, and the curve will look like this now. Y square is equal to minus 4ax is just a reflection of the standard curve about the y-axis, right? So what will happen is the focus will come on this side now. Focus will be minus a comma 0 for this curve. The directrix would be x is equal to a, would be the directrix. Vertex remains unchanged. Latest rectum remains unchanged. Tangent at the vertex remains unchanged. The x-axis also is unchanged, right? So you should know the relationship between these two curves. Similarly, you could have a standard equation of the parabola in this form also. X square is equal to 4ay, and also x square is equal to minus 4ay, right? So let's take these cases. This is a case where the parabola is about the y-axis. So this is the first graph. This is for x square is equal to 4ay. Here you would have focus here. This is 0 comma a. And the directrix will be y is equal to minus a. The same pattern will be there. Vertex will be 0, 0. Latest rectum will be 4a. The axis of the parabola now is x is equal to 0. And the tangent at vertex is y is equal to 0. So everything has been interchanged. And similarly, you will have a different situation if it was x square is equal to minus 4ay. Right? This is x square is equal to minus 4ay. The only thing that changes here is the focus and the directrix interchange their positions. So focus will become 0 comma minus a now, and directrix will become y is equal to a now for this parabola. So these graphs should be easily understood. Now let's look at what happens if we shift the parabola and the vertex of the parabola by a little bit. So what if the equation of the parabola is given by this, right? So here what has happened is instead of the vertex being at 0 comma 0, you can write this as capital Y square is equal to 4a capital X, where capital Y is equal to 0 and capital X is equal to 0 gives us the location of the vertex. So the vertex is no longer here. It might be somewhere here, which is h comma k. This point is h comma k. So this is the vertex being shifted, or the origin being shifted from 0, 0 to hk, right? So if this is the vertex, you will draw everything with this perspective. This line, which is x is equal to h, is the tangent at vertex. This line will be the axis of the parabola, and that will be y is equal to k. And the focus would be at, you will be shifting this by a unit. So it will be at h plus a comma k. That will be the focus. The directrix line would be here, which will be x is equal to h minus a, right? So that becomes your directrix, right? And the latest rectum is here, and latest rectum length is the same. So that is what happens when you shift the parabola by a little bit. This is the standard parabola y square is equal to 4ax being translated. You have shifted the vertex from 0, 0 to this point. The same thing could have been done in the other version also. X square is equal to 4ay could also be shifted like this. And you can draw the graph for that also similarly. You should translate this parabola here. Now let's look at a slightly more complicated case where we have an oblique parabola. Okay. So what do we mean by an oblique parabola? This is the situation where the axis of the parabola or the focus and the directrix are not nice situations like this. Usually we have directrix like this, which was a vertical line, and focus was a point like this, right? But what if the directrix line is not a vertical line, right? It could be that the directrix is something like this, right? In which case the axis would be like this. The axis would be like this, and the focus would be somewhere here, let's say, and the parabola could be like this, right? So this is the type of situation where you call it an oblique parabola, right? So here the directrix is not a vertical line, it is a general line. It could be written with any equation. You could write it as ax plus by plus c is equal to 0 or something like this, right? So let's think about how we would write the general equation of a parabola in this case. Okay, so let's think about it. X minus alpha whole square plus y minus beta whole square. Let's say that this is equal to Lx plus my plus n whole square by L square plus m square. What have I written here? If you think this is Pxy and this side is square of distance of Px comma y from the known point alpha comma beta. So obviously alpha comma beta becomes our focus, and this is basically Ps square. And here I have written Pm square, which is the square of perpendicular from variable point Pxy to the line Lx plus my plus n is equal to 0, right? So this line is our directrix. So in general, when you have a situation where the directrix is not a nice vertical line, you should write the standard equation by this method. This is Ps square is equal to Pm square. That is what I am doing, right? So here, what we know for sure is that the focus is the point alpha beta and the directrix is the line Lx plus my plus n. So what else can we say from here? Obviously, we know that the axis is perpendicular to the directrix. And since the directrix was given as Lx plus my plus n, the axis will be perpendicular to it and pass through alpha beta, right? So using these two conditions, we can actually find the axis of the parabola. So I'll do that on the next screen. So let's say we have a situation like this. This is my oblique parabola given to me whole square by L square plus m square. And now I want to find the equation of the axis. Equation of the axis. So how do I do that? I know my directrix is Lx plus my plus n equals to 0. So any line perpendicular to that would be mx minus ly plus some constant equals 0, right? This is a line that is perpendicular to directrix. But this line should also pass through alpha beta, right? Because alpha beta is my focus. So alpha beta lies on axis. So you put that here, you get m alpha minus L beta plus C equals 0. So C is coming out to be L beta minus m alpha. Therefore, my line equation is mx minus Ly plus L beta minus m alpha equals 0, which can be written as m times x minus alpha plus minus L times y minus beta equals 0. So this equation becomes equation of the axis. Okay. So once you have an oblique parabola whose directrix line was given to you, you can find the equation of the axis if you know the focus, right? So this is the process to do that. Another thing to understand from this equation is a general property. If you have x minus alpha whole square plus y minus beta whole square is equal to Lx plus my plus n whole square by L square plus m square. What you can do is convert this equation a little bit and make it look like this. Mx minus Ly whole square plus 2gx plus 2fy plus c equals 0. Why am I saying it can be converted like this? Notice from this side, what are the square terms that you are getting? L square x square plus m square y square. Okay. And you are getting a 2lmxy right here. Correct? These are the quadratic terms on the right hand side. What are the quadratic terms on the left hand side? If you cross multiply with L square plus M square, you get L square plus M square X square plus L square plus M square Y square, right? There is no XY term on the left hand side, right? So if you collect all the quadratic terms on the LHS and the RHS and bring everything to one side, so let's bring all of these three quadratic terms to this side, you will end up with M square X square plus L square Y square minus 2lmxy, right? So that is what I'm writing here. Basically, I can write this as mx minus ly whole square. Why is this important? It is important because this general oblique parabola equation is coming out like this, that all the quadratic terms, all the 2-degree terms form a perfect square. Form a perfect square. Notice that there are other terms. Here there will be an x term and a y term, and here there will be x term and y term, and those have been combined in these three here. So there is nothing special about the other terms, but what you can say for sure is that all the second degree terms, 2-degree terms, either in x or in y, it could be x squared, it could be y squared, or it could be an xy term, they will form a perfect square. And that is a property of the parabola. So this is a general property that you should be aware of, that if the second degree terms in the general equation of a conic form a perfect square, then it is a parabola. So that is one way to recognize a parabola. Okay. So for example, suppose you have an equation like this, y is equal to ax square plus bx plus c, right? We know this is a quadratic and this is a parabola. But notice that the second degree term is a perfect square here, right? You should also know how to plot these types of graphs, y is equal to ax square plus bx plus c, and find its latest rectum and stuff. The way to do that would be to realize that you can complete the square and write it like this: plus 2ac minus b square, 4ac minus b square by 2a and stuff. You know how to do the quadratic completing the square stuff. And from there, it will be easy to figure out the graph of this function, because it will start looking like this is a constant which you can bring to the other side. Y minus k is equal to a times x minus b by 2a whole square. So technically, you have some constant 1 by a, y minus k is equal to x minus b by 2a whole square. And this is in the form x square is equal to, this is in the form x square is equal to 4 capital A y. And we know how to draw the graph of that times parabola, right? So you should know how to do that part. Another property that is super important is this property. This is my general parabola. This is a random point P on it. This is my directrix. X is equal to minus A. Let's say this is my focus, A comma 0. The equation of this parabola is y square is equal to 4ax, right? Now this point's coordinate is x comma y. What you can think about is drop a perpendicular from this point P to the principal axis. So let's call this PM. This is perpendicular, and drop a perpendicular from point P to the tangent at the vertex. This line is my tangent at vertex. So if I drop a perpendicular to here, this is N. So what we can see here is Pn distance is equal to the x, right? Because this was 0 comma 0. So Pn distance is x. and PM distance is actually equal to y. So you can clearly see that PM square is equal to 4a times Pn. Why? Because we know that the equation of the parabola is y square is equal to 4ax. So we can write y square as Pn square and 4a times Pn, right? So this is a standard property of the parabola, that Pm square is equal to, notice that 4a is the length of latus rectum, length of LR times Pn. What is Pm and Pn? Remember this property. P was a point on the parabola. From that point, we dropped a perpendicular on the axis. That was our Pn. And also a perpendicular on the tangent at the vertex. That was your Pn. And we have Pn square is equal to length of latus rectum times Pn. The reason this property is important is this property is a geometric statement. It's not a coordinate based statement. So this is a geometric statement which will be true for any parabola regardless of the standard equation. Like we know that the parabola equation is not always going to be so simple, right? Y square is equal to 4ax is the simplest equation. If it had been an oblique parabola, it would have been a much more complicated equation, right? But always, if there is a point P here, and this is the axis line, I can always say that the PM perpendicular and the PN perpendicular to the vertex, tangent at vertex, will be related by this relation. And here the constant here is the length of the latus rectum of the parabola. So that relation sometimes becomes handy when you're trying to solve problems. Okay, so remember that. The next topic that we will cover is position of a point with respect to a parabola. With respect to a parabola. By that, what we mean is, if you have a parabola like this, we can see that the parabola's curve divides the whole plane into two parts. This part is the interior, and this part is called the exterior of the parabola, right? And you can easily show that this part, the region which contains the focus, the interior part, any point inside the interior will always satisfy this condition. If this point P is x1, y1, and the equation of the parabola is y square minus 4ax equals 0, if you put x1, y1 into the parabola equation, it will come out to be negative. So if the point P was inside the parabola, in the interior region of the parabola, you can substitute y square minus 4ax in that equation. You can substitute the coordinates of this point, and the expression y square minus 4ax will come out to be negative. So if y1 square minus 4ax1 is less than 0, then we can say point x1, y1 lies inside the parabola. And if y1 square minus 4ax1 is greater than 0, then we can say that it lies outside the parabola. So this is an important idea. It is important because sometimes you have to decide where the point's location is. Okay, so now what we will do is a couple of questions which revises all the basic theory that we have learned so far. So far, what we have done is general conic definitions and parabolas equation in different forms. All the possible forms of a parabola equation we have seen. And we have also understood some basic properties and basic terminology. So let's look at some questions. So the first question is, find the equation of the parabola whose focus is 1 comma minus 7 and vertex is 1 comma minus 2, right? Okay. So focus and vertex are given, and notice that the x coordinate are of both of them are equal, right? So think about it. if the x coordinate of focus and vertex are equal, it cannot be a parabola like this because vertex and focus, the x coordinates are different. It cannot be a parabola like this. It has to be a parabola like this, right? Then only the x coordinates of focus and vertex are equal, right? Correct? So we have a situation like this. The focus is 1 comma minus 7 and this is 1 comma minus 2. So obviously you can see that it cannot be an upward facing parabola, right? First thing that we know is the axis of the parabola is parallel to the y-axis. Axis is parallel to y-axis. And notice that the focus is lower value than the vertex. So that means it must be a parabola like this, right? So technically, we have a situation where the equation should be x square is equal to minus 4ay, something like this, right? This is the general equation that we could have. However, we don't know whether the axis is on the y-axis. So in general, what we can say is the equation of this parabola will be of the form x minus alpha whole square is equal to minus 4a y minus beta. Because right now I don't know whether the vertex is, actually know that the vertex has been shifted. Vertex is 1 comma minus 2, right? So it should be x minus 1 whole square is minus 4a y minus 2. So this becomes x minus 1 whole square is equal to minus 4a y plus 2. And now we have to also know that the distance between the focus and the vertex, right? Here in this problem, the distance between focus and vertex, SV distance is 5. But usually that distance is 1/4 of latest rectum, right? So that means our latest rectum should be 20. And latest rectum is basically going to be this constant. So 4a must be 20. So my equation should be x minus 1 whole square is equal to minus 20 y plus 2. Right? That becomes the equation of our parabola. Notice how by knowledge of focus and vertex, we found the equation. Because the vertex was not 0, 0, therefore it has been a shifted parabola. It is a shifted parabola. And because the x coordinates were matching, we realized that the axis is parallel to the y-axis, right? Let's do another problem. Question 2. Find the equation of a parabola whose focus is minus 2 comma 3 and directrix is 2x plus 3y is equal to 4. So this is a very easy question. Whenever they give you focus and directrix, all you have to do is think of this as S and think of this line as M and do PS is equal to PM. That's the basic definition of a parabola, right? So when you do PS square is equal to PM square, you will get the answer. What is PS? PS is the distance of my point P, which is x comma y, from my focus minus 2 comma 3. So it will be x plus 2 whole square plus y minus 3 whole square root of that. And that will be equal to PM, which will be distance of x comma y from this line. So it will be 2x plus 3y minus 4 modulus by root over 4 plus 9. So root 13. If you square this and simplify, you will get the answer, right? So that was a pretty easy one. Let's look at another problem. Find the coordinates. Find the coordinates of the points on the parabola. Y square is equal to 2x, whose focal distance is equal to 5 by 2. Okay, so first of all, notice that it's a standard parabola. Y square is equal to 4ax. The equation is y square is 2x, so that means a is equal to half. And now the standard property of this parabola, we saw in the previous class that the focal distance of any point, focal distance of P, which was x comma y, is equal to simply x plus a, right? So now x plus a is 1/2, and focal distance is given as 5/2. That automatically gives us x is equal to 2. And if x is 2, y can be plus or minus 2, right? So there are 2 points, 2 comma 2 and 2 comma minus 2, that satisfy this condition. The focal distance of both these points will be equal to 5/2. This is a very important result that I discussed in the previous class. So if you don't remember it, please go back and see if you are understanding that proof. Right. Let's look at another problem. Question 4. Here we say find the equation of a parabola whose focus is 3, 5, whose focus is 3, 5, and vertex is 1, 3. This was a JEE 2019 question. So we are given S, which is focus is 3, 5, and we are given the vertex. Vertex is 1, 3, right? So obviously, like, notice that there's nothing common between these coordinates. In general, you could have a situation like this. This is my vertex, this is my focus, right? And the parabola could be an oblique parabola in general, right? Now this line is my axis line. So technically, because focus and vertex are given, I know the equation of the axis, right? Can find the equation of the axis of the parabola, right? But we also know that here there will be a point where the directrix will meet. The directrix will be like this, and the directrix will be perpendicular to the axis. And one more fact that we know is that the vertex is the midpoint of the segment from focus to the point where the directrix meets the axis. This is obvious. We have seen this before, that this distance is equal to this distance. So since I know this is 3, 5, and I know this is 1, 3, I can find this third point, right? I can say that this unknown point is x plus 3/2 is 1, y plus 5/2 is 3. I'm using the fact that this x comma y and 3, 5's midpoint is 1, 3. So from here we can say x is equal to -1 and y is equal to +1. So this point is -1, 1, right? Great. And now that I know this point, I can easily find the equation of the directrix. Why? Because I can already find equation of my axis, right? Notice that this line joining vertex and focus is the axis. So the slope of this line we can immediately find. The slope of this line is 5 minus 3 by 3 minus 1, right? So that is 2/2, so slope is 1. So if slope of the axis is 1, slope of the directrix is -1. And now I can find equation of the directrix, because I know one point on the directrix is -1, 1. So the equation is y minus 1 is equal to -1 x minus -1. So this becomes y minus 1 is minus x minus 1. So y plus x equals 0. So y plus x equals 0 is my directrix, and we already know the focus. So now the problem becomes very easy. We just have to do PS is equal to PM for a random point x comma y on the curve, right? And we will be able to find the equation of the parabola now. So that is how we solve this particular question. Okay. Now, what we will do is we will stop at this point for today's class. In the next class, I will do more problems, and then after we do some more problems, what we will go and do is tangents and normals. So the remaining theory of the chapter, we will start covering from the next class. I just want you to make sure that you go through the previous video and today's video and understand how all the different forms of a parabola make sense. all the terms should make sense to you. The graphs should be obvious, and how we are approaching problems based on the definition and the different standard forms of a parabola, that should be clear to you. So take your time and revise through everything we have done. Make notes for it. If you have some doubts, let me know in the comments. We will continue with the next video, and there we'll do some more problems and start doing some properties like tangents and normals of a parabola, right? So we'll get on with more theory and problems in the next video. That's all for now. If you like the content, please subscribe to the channel and share it with your friends. All your support will be very crucial for me. So thank you for all that. I'll see you next time.